We now have our fourth question here. Find the work done by a force F equals 3I plus 3j minus 6k through a distance R equals 4I plus 5j plus 4k and the direction of the force. Now, we are asked to find the work done. It's important for us first to know that work done is a scalar quantity. And because it is a scalar quantity, in order to obtain the value of this work done, all we have to do is to solve that work W is equal to F dot this distance R. That is actually radial distance anyway. Okay, this dot here is pronounced dot product or scalar product. Are you following, right? It's actually a form of multiplication, one of the ways in which vectors can be multiplied. Remember in question 1, I talked about a cross product, right? So we have another called the dot product. Either I call it dot product or scalar product. So that's the symbol. And because work is a scalar quantity, to obtain the value of work, you simply do the dot product, the scalar product of the force and the distance. So solving for this, we are going to get our first vector is 3I plus 3j minus 6k. Then dot, our distance given is 4I plus 5j plus 4k. Now, in carrying out dot product, remember I stated previously that you have to take them like term by like term, just like you do addition and subtraction. Is that okay? So that being the case, our work done is going to be equal to 3I dot 4I. Now, when you're doing 3I dot 4I, this is what you want to take note of. Multiply the scalar components, the numbers. 3 times 4 will give us 12. So that's going to be 12. Now we have I dot I. Please, based on the definition of scalar product of two quantities, based on the definition, I dot I is equal to J dot J is equal to K dot K, and the answer is always 1. Now let us move on to what we have here. So if I dot I is equal to 1, 1 times that 12 will give us 12. In scalar product, dot product, simply add up the things you're going to get. Is that okay? So next we move on to the J component, and then 3 dot 5, which is 3 times 5. It's going to give us 15. So we have our 15 there, and then plus. Next we move on to the K component, minus 6 times 4, which is going to give us minus 24. Working this out, 12 plus this is going to give us 27. 27 plus minus 24 will give us 3. That's 27 minus 24, which is 3. Then of course you have joule there, which to put a unit. Okay? This is the work done. Unfortunately, there is no option here that has that value 3, which means that the correct option is not in these ones provided. But that doesn't matter. I'd like us to see the end of this. Let us get the direction of the force as required. Are you getting? To get the direction, whenever you are exposed to scalar product of vectors, direction is obtained by getting the cos inverse of the scalar of the dot product divided by the multiplication, the product of the magnitude of the vectors. Theta equal to cos inverse of this scalar product, that is F dot R divided by magnitude of F times magnitude of R. This is the formula we use in obtaining the angle. That angle gives us the direction. So this is going to be cos inverse of F dot R already is 3. Okay, it's 3. So it's going to be divided by magnitude of the force. Please, let's work it out once. So you come to this first vector and get the magnitude using Pythagoras theorem. How do you go about that? Square root of 3 square plus 3 square plus 6 square. 3 square is 9. Another 3 square is 9. You add, you get 18. Then 6 square is 36. You add, you get 54. So that's going to be square root of 54. So this is going to be multiplied by the magnitude of the distance here given. This is 4 square giving us 16. Another 4 square giving us 16. Then 5 square giving us 25. If you have 16, you're going to get 32. Then 32 plus 25 is going to give us 57. So that's going to be square root of 57. If you work this out with your calculator, yeah, I've got to reach out to calculator this time around. Okay, so that's cos inverse of 3 divided by square root of Since this is multiplication, you can simply use square root of 54 times 57, okay? And working this out, this is what it gave to me. 86.9 degrees. So this is supposedly the direction of the force, which means that in putting the result together, we expect to get 3,86.9 degrees. Unfortunately, that is not in this option, but it's not our business anyway. We've done what our business is, which is get the question solved. I hope you're enjoying this. This is just a tip of an iceberg of more of the things you can gain from GMAT 41. Like I say, at full ground for now. The question now is, you're they ready to make use of GMAT 41? Are you ready to use the GMAT 41? Our God and helper, Jehovah, will continue to move us from strength to strength. You can be part of us so that you get excellent grades. First class is the language I understand. Now let us move on to our next question, number 5. Starting from a given point, a car travels east 84 km and then turns due south for another 193 km. Determine the displacement of the stopped car from its starting point. We have to determine the displacement of this car. Now it's important for me to say this quickly, that this is a two-dimensional vector. Displacement is a vector quantity. Solving this is simple. If you like, you can sketch the diagram. If you don't want, you can just leave it. Sketching the diagram, you expect to get something like this. As simple as this. Then maybe we could take eastward and then southward, downward, alright? The east direction is 84 km, and then the south direction is 193 km. But it's a waste of time drawing this in example anyway, under this objective condition. So what are we expected to do here? Simply to get the displacement, permit me to use D for the displacement. The magnitude, simply move on. Because solving this, use Pythagoras theorem. This is a right angle triangle. The hypotenuse is our displacement. So it's going to be square of 84 and then plus square of 193. If you resolve this, you're going to get the displacement to be 210.49 meter. So this is the correct answer, the displacement of the stopped car. Quite simple, you know. So the correct option is option D. Our sixth question, given the vectors A equals 4i plus 2j minus k, then vector B equal to 2i minus j plus k, vector C equal to I plus j plus 2k. Now we are required to find A plus B dot C. So once again, it's a simple question, right? Play around with it. Now we know how to carry out addition and subtraction of vectors already. So we are going to follow this in order of arithmetics. We have brackets here. So we have to evaluate the bracket first. Anything we obtain from here, we'll now do a dot product of that vector with vector C. That's just what we are expected to do here. So solving for A plus B and then dot C. Let me bring out the vectors, even though it's not necessary to bring out the vectors. If it is an example, just attack straight. This is CBT. You know, A plus B, 4 plus 2, you get 6i. 2 plus minus 1 would give you 1j, you know. And then, of course, minus 1k, which is simply minus 1, plus 1 will give you 0. The k guy goes off. That gives you a two-dimensional vector, which you now do its scalar product with vector C. And you can still move on to solve that without showing any solving. The network of your brain, I tell you, is sufficient to do the work for you. God has created something wonderful. But let's go. All right, this is 4i plus 2j minus k. Then we are adding this to the vector 2i minus j plus k. Now, whatever we get from here, it is going to be multiplied by vector c. And vector c, we have it to be I plus j plus 2k. Good. So finish up with the bracket first, this, okay? And that, I said, is going to give us 4 plus 2, and that is 6i. Then 2j, or simply 2 plus minus, which is 2 minus 1, will give us 1. 1 times j will give us plus j. Then minus 1 plus 1 here will give you 0. 0 times k is 0, so that guy goes off. So we'll have it dot c, and the vector c is I plus j plus 2k. So we're just going to work this out. 6i dot I. Simply 6.1 or 6 times 1, which is going to give us what? 6. Remember, like I said, I dot I is equal to what? 1. That 1 times 6 will give us what? 6. Then we move on and introduce our plus. So our J component, this is the coefficient here, is 1. 1 times 1 here is also going to give us 1. Alright. Now we are left with k components in vector C. But if you look at this vector, which is a plus b, there is no k component there, no k. It simply means that the k component there is 0. Are you following, right? Whereby there is no k here and we have k here. It simply means that the k value here, its scalar component is 0. So that if you have 0k or 0 times k, it will disappear, it will go off. Do you understand that? So handling the other guy is going to be 0, which you are not seeing. I've told you why. Multiply it by 2k there, and then you get what? 0. So is it clearly that the vector resolution here, what it wants us to do, vector a plus b, and then dot vector c, is going to give us, if you add up this, you get 7. And you see clearly that the correct answer is C. Please, I want to say this, alright, that this question given to you could have been A minus B dot C, or A plus B cross C, or A minus B cross C. Your examiner can tell you to carry out any of the arithmetics on vectors. And if you're asking you of such arithmetics, follow the procedure of what you know about that algebra of vectors. By the way, do take note that this operation we are asked to carry out, this algebra, a plus b in bracket dot c, one can choose to punish himself in this way. You do a dot c plus b dot c, which simply means that scalar product distributes over addition and subtraction. But it's still going to give you the same result. Alright guys, I hope you enjoyed this class. Please give the GMAT 41 thumbs up. Wait now, they do not be bad thing, no. Now good thing. Remember, as long as you're a student, your academic future is linked to all of these which GMAT 41 is putting out. Please support this channel. Let's grow and continue to give you the best. Just below this video, you have the Join tab. Click on that Join tab, select the package that's convenient for you. However, to access the GMAT 41's materials completely, please kindly select the Platinum level, okay? And you can be assured of the best from GMAT 41 anytime, any day. Don't forget, if you wish to join the GMAT 41's physical tutorial class on campus in Unizik, please feel free to contact me. Is that okay? Use the number showing on the screen in order to get further details on our classes and where it holds in Unizik campus. I hope to see you in my next class. Yeah, just get ready. We will be treating past questions and answers, their solutions on aspects of dimensional analysis, circular motion, dynamic motion, work energy and power, and many more. You will not want to miss that, right? Please take note that the past questions considered so far are those extracted from 2017 down to this current year. So you want to follow up, and I will continue to update this channel with other years as they come. Make sure you are together with us. Please subscribe to this channel if you have not already done so. Help to share the GMAT 41's videos. Invite other friends, classmates, and scholars to subscribe to this channel so I will continue to mentor you. I will see you in our next class. Until then, don't forget, remember to take your studies seriously.